The Chinese research probe, which is currently on Mars, has managed to collect a series of truly unusual and fundamentally new data about the red planet, once again posing one of the most exciting questions to scientists. Was there, or even is there, still life on Mars? And have Chinese experts come closer than others to unraveling this mystery? The Zhurong rover belongs to Mid-Level Devices, and in its design is largely similar to the American rovers Spirit and Opportunity from 2004, acting as their functional equivalent. But despite this similarity, for the first attempt of the Chinese space program in a successful landing on Mars, it became a truly significant and landmark success. The launch of Zhurong took place as part of the Tianwen-1 mission in 2020, and by that time China already had experience with 2 successful landings on the surface of the Moon. However, the transition from the Moon to Mars meant a step into a completely different, much more complex and dangerous world, which made this attempt especially bold. Before China, successfully landing a spacecraft on Mars had been achieved by only 3 state programs. The first was the Soviet program, when in 1971 the Mars 3 lander reached the planet's surface, deployed equipment, managed to transmit just one blurry and almost unrecognizable image of the Martian landscape, and after that fell silent forever. A little-known fact remains that the United Kingdom also tried to reach the surface of Mars. In 2003 to 2004, a small Beagle 2 lander was sent there, which, according to the official version, could not fully deploy its solar panels, due to which it never received the necessary power. Of course, NASA stands out separately. The space agency that, starting from 1976 and the Viking missions, has been almost continuously studying Mars, sending there both stationary landers and large rovers equipped with radioisotope nuclear generators, and quite recently even delivered a microhelicopter to the planet, which made the first controlled flight in history beyond Earth. Therefore, when China announced its intention to join the narrow club of countries capable not only of flying to Mars, but also of softly landing a spacecraft there, many experts assess the chances of success as quite modest. However, the Chinese program sought to minimize risks as much as possible, and chose for Zhurong's landing a relatively flat and, at first glance, safe area in the Utopia Planitia region, in the northern hemisphere of Mars, which, according to a number of hypotheses, several billion years ago was covered by a gigantic ocean. At the same time, the American rover Perseverance, also launched in 2020, was directed to the neighboring Jezero crater, a geologically much more complex area with rocky hills, traces of ancient riverbeds, and a multitude of diverse structures. Nevertheless, even though the landing site chosen by China appeared flat and relatively simple, it was by no means empty or boring, since beneath the surface sands of Utopia Planitia lay an ancient and intriguing mystery, which perhaps for the first time in decades was touched upon precisely by the Chinese rover. It is noteworthy that it was in this region in 1976 that the American Viking 2 apparatus landed, and there is an opinion that it was there that the United States might have first discovered signs of life on Mars, and simultaneously destroyed them. According to official NASA reports, Viking did not detect any evidence of life, however, in the scientific community. The strange results of the analysis of Martian soil collected by this apparatus are still discussed. In the 1970s, scientists had a very vague idea of the real conditions on Mars, and many of them seriously allowed for the presence of microorganisms on the planet. The experiment conducted on board Viking looked like this. A sample of Martian regolith was placed in a special chamber inside the lander, after which water with dissolved nutrients was added to it, expecting that any living microorganisms would begin to consume this liquid and release carbon dioxide as a product of their vital activity. And indeed, after adding the liquid, the instruments recorded the appearance of CO2, which at first glance looked like direct confirmation of biological activity. However, the experiment had a second phase. The scientists added even more nutrient moisture, expecting an intensification of the reaction, but instead, the amount of released carbon dioxide unexpectedly decreased. NASA concluded that the observed effect does not have a biological nature and indicates the absence of life. Nevertheless, some specialists suggested an alternative explanation. If extremely drought-resistant forms of microbial life existed on Mars, then sudden and excessive moistening could simply kill them. In other words, perhaps the researchers unintentionally drowned the Martian microorganisms. This little-known story emphasizes that Zhurong was working in a region where one could really expect to discover something unusual, even despite the apparent geological simplicity of the terrain. The Chinese rover successfully reached the surface using a landing scheme proven over decades, largely reminiscent of the methods of the Viking era. First, the apparatus was slowed down by a parachute in the rarefied atmosphere. Then its separation occurred. The braking rocket engine was activated, which reduced the speed and shut off directly before touching the surface, allowing the shock-absorbing supports to complete the soft landing. After that, the landing platform deployed a ramp. Zhurong unfolded its solar panels and set off on its journey, becoming the second national program in history after NASA to deliver a fully operational rover to Mars. Initially, the mission was planned for just 90 Martian days, since solar panels are subject to gradual dust coverage, and Martian dust storms occur quite frequently, inevitably leading to energy loss. On board Zhurong were three key scientific instruments: a camera system, a laser device for destroying rocks to analyze their internal composition, and a powerful ground-penetrating radar capable of probing the deep layers of Martian soil. It was this radar that allowed China to make one of the most intriguing discoveries in the entire history of Mars research. Beneath the surface of the sands, Zhurong began to detect numerous layers of minerals containing water. Over a section about 1.5 kilometers long, the instrument discovered 76 separate layers, lying at depths from 10 to 35 meters and inclined toward the northern lowlands, which indicated the existence of an ancient shoreline, the structure of which almost completely matched the shape of coastal zones on Earth. These layers formed as a result of water flows that drained from the highlands of the southern hemisphere into the Northern Ocean, and their depth indicates that water activity continued for tens of millions of years in a row. This became not just another confirmation that oceans existed on Mars, but also substantial evidence that the planet's surface remained wet for a very long time. However, whether this is sufficient for the emergence of life depends on the exact age of the water, since life requires not only the presence of a liquid environment, but also enormous time intervals for evolution. For a long time, it was believed that water disappeared from the surface of Mars more than 3 billion years ago. However, Zhurong's data casts doubt on these estimates. The deepest layers point to a massive flood about 3 billion years ago, while the upper layers indicate another major event approximately 1.6 billion years ago. This significantly shortens the so-called dry period of Mars, practically halving it, and creates the possibility that at the time when microbial life was actively forming on Earth, conditions on Mars could have been largely similar. But the most unexpected finds were made later. Moving across the desert plain, Zhurong began to explore long but low sand dunes about 30 meters long and approximately 1 meter high. Climbing to the top of one such dune, The apparatus discovered a solid salt crust up to 8 centimeters thick, covered with a network of cracks. Given the strength of Martian winds, such a crust could not form gradually, as it would have long been destroyed by dust storms. The most likely explanation was that in the past, liquid water soaked the surface of the dunes and then evaporated, leaving behind a solid salt deposit resembling cement in properties. Scientists suggest that water vapor evaporated from the northern ice caps of Mars, condensed, formed snow that fell on the ancient dried ocean bed, mixed with the salt remaining there, turned into meltwater, and briefly moistened the upper layers of the soil. Chinese studies have shown that similar processes could have occurred just about 400,000 years ago, that is, in a period when Neanderthals and early representatives of ancient humans already existed on Earth. These data allow us to assume that the climate of Mars is subject to long cycles of warming and cooling, associated with changes in the planet's orbit and axial tilt, similar to Earth's Milankovitch cycles. Such cycles change the amount of solar energy received by the surface and can lead to temporary warming of the poles, melting of ice, formation of water vapor, snowfalls, and subsequent short-term appearance of liquid water. It is not excluded that every hundreds of millions or even billions of years, such cycles lead to water temporarily flooding vast areas of Mars, creating conditions favorable for the emergence and survival of microbial forms of life capable of enduring extremely long dry periods. Perhaps it was such organisms that existed in the past, and, it is not excluded, precisely them that the Viking apparatuses could have accidentally destroyed. As for Zhurong itself, it operated significantly longer than the planned 90 days, and in total functioned for 358 Martian days. In May 2022, the rover was put into sleep mode due to a powerful dust storm that completely blocked sunlight and deprived the apparatus of energy. After the end of the storm, specialists expected that it would be able to resume operation. However, communication was never restored, and Zhurong still remains unresponsive. Nevertheless, this story does not mean the end of China's participation in Martian research. Already in 2028, a new ambitious mission is planned to deliver the first samples of Martian soil in history to Earth, which will allow a full range of laboratory analyses unavailable to automatic instruments on rovers. It is these samples that may provide a clear and unambiguous answer to the question of whether life ever existed on Mars, and humanity hopes that next time we will be more careful and not destroy what we may discover, although completely excluding a repetition of history is still impossible. Regardless of this, thanks to Zhurong, a new chapter has begun in the history of Mars exploration. Its discoveries have significantly expanded our understanding of the planet's past, its climate, ancient oceans, and potential habitability. And now, as missions to deliver samples become closer, the final answers may be quite near. Friends, share in the comments. What do you think about this story? If the video was interesting, support us with a like and subscription to the channel. Until new meetings.